Video I'm going to discuss about singly linked list. In my previous video already I would have explained about what is linked list and what is the advantage of using linked list structure and the actual memory representation, as well as what are the types of linked list. Everything was discussed in the previous video. In this video, I'm going to discuss about the singly linked list. As we all know, linked list is a linear collection of data elements. Data elements are nothing but nodes. So this is how the node will be. Like each node will look like. There will be two fields. One is data field, where we can store the action information in it, and the next is the next field where we'll store the address of the next node in the list, right? So imagine like I'm just going to show the singly linked list structure now. So collection of nodes is what the linked list, right? So imagine that there are 3 nodes in the list. I just want to store the data elements 5, 10 and 15. These 3 elements I would just want to store using linked list data structure. So 3 nodes are actually required, right, to store 3 values. So okay, 3 nodes are here, right? Each node has 2 fields, data field as well as the next field. So in the data field we can store the actual data, and in the link field we will store the address of the next node actually. So each and every node's address are AA, BB, and the third node's address is CC, which means at the place of AA the first node is stored, at the address BB second node is stored, and under the address CC the third node is actually available, right? So the next field should always have the address of its next node, right? So after 5 it has to go and process the value 10. The 10 is stored at the address location BB. So I'm writing BB here, which means after processing A it has to go to BB, right? So AA and BB is connected now. Why? Because after processing AA it has to go to the address BB here, right? Then again the third value 15 I need to process. 15 is stored at the address location 3 CC. Address is CC, which means after processing the node BB it has to go to the node CC, right? So these two are interlinked, right? After processing CC, only 3 elements I just want to store, so only 3 nodes are actually required, no more values to store actually. So the always the last field, the next field of the last node will have always the null value. Why? Because there is no more node after this. So always the next field in the last node will hold only the null value. Now okay, right, the address of BB is stored in the previous node AA, the address of CC is stored in the previous node BB. What about this address of the starting node AA? So to store the address of the starting node, the very first node, we are just going to use one start variable where we can store the address of the first node. So always we are supposed to start from the start node. So it will start from the start variable, start node. So start node's address will be stored under the start variable. So here it will check the start variable. Under the start variable there is an address AA. So it has to process AA first. After processing AA, it will check the next field, there is BB, which means after processing AA, it has to go to the location BB and process the data. Then again after processing the data which has been given in the memory location BB, it will check the next field of it, there is CC, so next it has to go to CC and it will process the data. Again it will check the next field, since the next field is null, it will stop the process. So this is how the linked list, the singly linked list structure will be, and this is how the data also will get processed. So now let's write an algorithm for performing the traversal operations. Traversing a linked list. Let's write a pseudocode for performing the traversal operation. We'll take the same example. Okay, how to write the pseudocode for performing traversals. Okay, so traversal in the sense the processing each and every data which has been given in the list. So it will process the data one by one. So always we have to start from the start location only, right? So randomly we cannot access the data here. Randomly we'll be able to store the data in the linked list, but random accessing of the data is not possible in the linked list. Whereas in array, using the index position, randomly whichever the element you want to access it, we can go to the particular index and access the element. But when it comes to the linked list, like continue the we can in the sequential manner only will be able to access the data actually. So always you have to start from the start location only. So since I want to perform the traversal operation, I have to traverse right from the first node till the last node in the list. So the very first step should be, you are just going to use one pointer. You are just going to set pointer equals to start, which means the pointer will be pointing the start only. What is given in the start? That is AA, right? So my pointer will be pointing AA because we have to start from the start node, right? Now until the last node we are supposed to process each and every node, right? So we are just going to use loop over here. So use while loop here. Until when will be traversing? Until the last node in the list. So how will you identify the last node in the list? When there is a null value in the next field, we could say that is the last node, right? So until pointer is not equals to null, we can continue doing the traversing operation here, right? So until the pointers next is not equal to null, we can keep traversing the node. So first it will be pointing the start. We check whether the pointer is not equal to null. Yes, the pointer is not equal to null because we have address in it. So you can process the data which has been given under the data field. So the pointer is pointing AA. We are processing the data field of AA here. Once printing the data which has been given under the data field, we are supposed to move on. We are supposed to move the pointer to its next position, right? How will you move the pointer? Set point. Initially your pointer was pointing the start. Now we are just going to increment the pointer's position. I like usually in the array, like you are using the for loop here. If you want to perform the traversal operation, first it will be pointing, like I is pointing 1. After processing this data, we will be performing I plus plus, right? Since we have a node structure, we have used the structures here, like we have the data field as well as the link field here. Directly you cannot increment the pointer position. So you are just going to move the pointer to its pointer's next position. Now my pointer is pointing AA. The next step is you are going to move the pointer to its next position. So you can write like this: pointer equals to pointer next, which means my pointer is pointing AA. Now my pointer should be pointer equal to pointers next. So pointer is pointing AA. What is pointer is my pointer is here. My pointers next is what? BB, right? Which is like point the next field, what is given? BB is given. If so, the next iteration, my pointer will be moved to the address location BB. Pointer equal to pointers next. Now check whether the pointer is not equal to null. Yes, the pointer is not equal to null only. So now print the next data also. Initially at the first iteration it will print 5, in the second iteration it will print 10, right? So after printing, again we are supposed to increment the pointer. So how will you increment the pointer? Pointer equal to pointer next. In pointer next, CC is given. If so, at the next step the pointer will be moved on to the next node, to the address location CC. Now check again the pointer whether the pointer is not equal to null. Yes, the pointer is not equal to null only. So print the data, that is 15. Right? After printing the data 15, the pointer will be incremented to its next position. So when you check pointer's next position, it is null. If so, it will stop, right? So it will stop traversing. So end of loop, exit. So this is the pseudocode for performing traversal operation. Now let's write an algorithm to count the number of nodes in a linked list. Okay. Now you want to print the number of nodes. Print the number of nodes in a linked list. How will you do it? same pseudocode can be used. The only difference is every time after processing the data, we are supposed to add the count as well after processing each and every data, right? So finally it has to print the count, how many number of nodes were there in the linked list, it has to print, right? So as a first step, use this, I'm explaining the pseudocode for printing the number of nodes in a linked list. The very first step is set count equals to 0. The only extra step is set count equals to 0. So initially the count will be 0. As usual, set pointer equals to start. Your pointer will be pointing the start until when it has to process till the last node, because we need to count the number of nodes in the entire list, right? So until the last node. How will we identify the last node? When the next field is null, we could say that is the last node, right? So we are just going to use the loop, and the condition is going to be pointer is not equals to null. So after processing each and every data, the next step is before you increment the pointer, you just add the count. Set count equals to count plus 1. So initially the count was 0, pointer is pointing start. I am checking whether the pointer is not equal to null. Yes, pointer is not equals to null. So after processing the first, the start variable, which is a, I am just incrementing my count value. Initially it was 0, now the count value will be 1. So now the count will be 1, right? After adding the count, you are going to increment the pointer equal to pointers next. So now the pointer will be here at the second position. Again you are going to check whether the pointer is not equal to null. Yes, it is not equal to null. If so, increment the count again. Your count was actually 1, the current count value is 1 plus 1, which will be 2. So now the updated count value will be 2. Then again check where increment the pointer. After incrementing the pointer will be at the third position. Check again, pointer is not equal to null. Yes, pointer is not equal to null. Again you just increment the count. Your current count value is 2. After processing this, after accessing this node, again you are supposed to increment your count value, which is plus 1, that is 3. So now your current count value is 3. After incrementing the count value, again you are supposed to increment your pointer. When you increment the pointer to the pointers next, it is null, so it will stop till here. So what is your current count value now? So end of loop and write count here, print count, then exit. What is your count? It will return the count value here. Totally the count value is 3. So this is how, using the linked list data structure, we are supposed to write the pseudocode. So if you want to refer the data field, for example, there is a pointer, you are just going to use the pointer to process each and to point to access each and every node. If you want to refer the data field, you are supposed to write like this, pointer data, which means you are referring the data field. Pointer equals to pointer data means it will be referring the data field only. Suppose if you want to refer the next field, means the pointer is pointing a particular node. If you want to process the data field, means pointer arrow data should be written. Suppose if you want to refer the next field, means pointer arrow pointers next. So this is how we are supposed to, using the linked list data structure, we have to write the pseudocode. So in my upcoming videos, I'm going to discuss the operations in linked list, like 2 major operations there always, like any data structure. If you take the major operations, there are multiple operations are there, but 2 major operations are insertion and deletion. Other than that, traversal, searching, many other operations also there, but we'll discuss only insertion and deletion and under all the types of linked list. In my upcoming videos, singly linked list insertion as well as deletions will be discussed. Thank you.